How everybody doing? My name is Tracy Sanders, and I am going to be talking about the nuclear energy and space exploration today. Introduction. Before today's time, humans was having a lack of technology for a long period space exploration, and the Department of Energy made these flights possible. And the Office of Space and Defense Power Systems developed radioisotopes power systems for NASA just for these long explorations. Some history about nuclear exploration in spacecrafts. In 1961, the U.S. Navy's Transit 4A, it was a navigation satellite, was the first spacecraft powered by nuclear energy. And this was powered by radioisotope thermoelectric generators, aka RTGs, and that produced 2.7 watts of power. Now, back then, that was a lot of watts of power. Like, that could power a lot of things. But today, it wouldn't mean nothing. But in 1969, the first nuclear weather satellite was launched using RTGs also. So, RTGs been a thing in technology for a pretty good long time. And these were developed by the Atomic Energy Commission, who were the predecessors to the Energy Department Office of Space and Defense Power Systems. And right here is a picture of one of the first, it was the Navy's Transit 4A satellite. And that's a picture of the satellite right here. So how was nuclear energy used in space exploration? Now that's the big part we were looking for. NASA used two methods for long space travel, okay? Energy from the sun rays and heat generated by radioactive decay, basically nuclear energy. Radioisotope power system converted heat that is generated by plutonium-238. And this type of plutonium was only used in space travel, nowhere else. And this plutonium is then generated into electricity. And the reason for this use of certain type of plutonium is that it has a half-life of 88 years, 1. 2, it has stable high temperatures. 3, it generates small amount of heat. And 4, it emits low level of radiation, so you're not getting that much radiation poisoning by these RTGs. And basically, RTGs again, these are generators that convert heat from decaying plutonium-238 into electricity using thermocouples. Some basic first explorations using nuclear energy that really set it off was in 1989, Galileo was the first spacecraft to orbit Jupiter powered by 2 RTGs. And this discovered water on Europa and volcanoes on below. And these are the moons for Jupiter. So that was one of the first big explorations by using nuclear power. In 1990, the Ulysses was the mission launch study the heliosphere, and this was powered by general purpose heat source radioisotopes, aka GPHS RTGs. And this discovered solar storms, solar wind, interstellar dust particles, and cosmic radiation. Basically, all weather that you see in space. And some advanced space missions that use nuclear energy that really set it off for space exploration. In 1970, Pioneer 10 and 11 were powered by 4 RTGs were designed to travel far. Like, these were designed to travel very, very, very far. And this design was only supposed to last 5 years, but instead, operated for 3 decades, so it really did its thing. Voyagers 1 and 2 were Pioneer's legacy, And these were deemed, like these two missions was deemed as one of the most important missions in exploration to date. Because we discovered the moon with these. So you feel me? These spacecrafts use 3 multi-100-watt radioisotopes thermoelectric generators. Okay. Hear me out. Multi-wattage. So when the very first nuclear satellite used RTGs, it only produced 2.7 watts of power. Now we're talking about using a multi-100-watt radioisotopes. So I'm gonna let y'all do the comparison on that. The most recent nuclear mission that is known to date was in 2011, the Curiosity, that relied on one multi-mission thermoelectric generator. And this was a mission that sent the rover to Mars to study the environment of the red planet. And after that, thank you for joining my presentation, and I hope you have a great rest of your day. Thank you.